Forgot one thing from the previous video, the application of neutralization, we call titration. You'll learn about titration in a little bit later in this chapter, but I just want to show you first. A titration is a technique for, as some of you remember the gravitational analysis. So that's how it's a technique for measuring a concentration of an unknown solution. Titration, similar to that, but to measure the acidity of an unknown solution, basically. All right. Let's say if we have an unknown solution of hydrochloric acid, so we're gonna react hydrochloric acid with sodium hydroxide. We totally react the whole thing. Okay. And so we have hydrochloric acid right here. We have the solution of known solution of sodium hydroxide. Know the concentration, know the volume, react it. When it reacts completely, you can read the amount of sodium hydroxide that we use. We know the concentration. You can calculate for the amount of acid down here. Okay, we have a titration curve, but we'll talk about it later. Basically, all right. Now, just want to show you. So basically, the theory behind titration is moles of the acid equal to moles of base. All right, and we can convert mole to molarity times volume. Molarity times volume, very the same with the dilution equation, the same thing, but because they have the same mole, right? They react 1-to-1 ratio, right? So if you know the molarity of base, volume of base juice, and the volume of the unknown solution, you can calculate for the molarity of the acid, and so you can look at it right here. So molarity, molarity, how much volume do we use? And volume of hydrochloric acid, and then you can calculate for molarity of the acid. And how do we know when the acid and the base react completely? Well, we have an indicator to show when it change color. That's what it tells you. But you need to know which indicator to use. Okay, we'll get to that in a bit. All right, don't worry about it. All right, the second type reaction that involve acid and base. So acid can react with metal, and I'm sure you have seen this one time or maybe a few times. We call reduction oxidation reaction, right? All right, so when you have magnesium strip dip into a solution of hydrochloric acid, so you're gonna get. Can you predict what product you get? Yeah, pause the video right here and predict for me real quick what you get. This is an example of a single displacement reaction. So magnesium go pair with chlorine, you get magnesium chloride. And hydrogen, what do you get? 2H? No, you get hydrogen gas. Yeah, you get hydrogen gas right there. All right. So acid react with metal. We also call reduction oxidation reaction. If you still remember, what is oxidation number of just an element, just metal in nature, exists in nature? 0. So there's no reaction. So everything you see have a 0 charge because they're neutral, they're stable, they can exist in nature. So magnesium is 0. Okay. And but magnesium chloride, so this magnesium already loses electron, become +2. That is an oxidation reaction. So increase in oxidation number. Now, hydrogen, right? Hydrogen in hydrochloric acid is +1 because chlorine is -1, right? Hydrogen gas, what's the oxidation number of hydrogen gas? H. 0. Gas in nature, right? Same thing. So element by itself is 0. +1 go down to 0. So decrease in oxidation number. So we call it reduction reaction. Okay. All right. Can you predict the product of this reaction? All right. I'll do it. Let's do this together. So iron and react with hydrochloric acid. So you can guess. Iron going to go pair up with chlorine, so we got ferric chloride or iron 3 chloride. Okay, and hydrogen going to become hydrogen gas. Yeah, balance out already. All right. So who's oxidized? Who reduced? Well, what's the oxidation of just iron in nature? Just iron, 0. Good. In compound, so iron loses electron, become +3. So 0 goes up to +3. Increase in oxidation number, so we call it oxidation reaction. And then hydrogen, same thing. So +1 in hydrogen gas is 0. So same thing, just like we saw earlier. +1 go down to 0. That's a reduction reaction. You know that? And so we have let's look at the picture. So we have a nail made of iron dip into the solution of hydrochloric acid, and you see the gas coming out. So basically, hydrochloric acid are reacting reacting with the iron, right? And iron coming out of the metal become iron 3 solution floating around in the solution. Yeah, leave it for a while, and the nail will just gone, just got eaten up by hydrochloric acid. Okay, some school have done this lab. I don't know if you get to do this lab. So the reaction of copper. So it's just one part of the this lab, but you get to see the color. So copper can react with a nitric acid, right, which is a strong acid. What happened is copper become copper nitrate, copper 2 nitrate, and we got a gas NO2 producing. If you remember, like in the equilibrium, so the previous chapter at the very beginning of when we talk about equilibrium, NO2 can react to each other, dimerize to N2O4. N2O4 is a colorless gas, but NO2 is a brown gas. So you see the brown gas right there, right? And copper metal, which is like a penny right here, become a copper 2 plus. In the solution of copper 2 plus, you have seen many times, is blue in color. So colorless solution of nitric acid turn kind of blue and really blue there. All right. Yeah. And some of the penny got eaten up right there. Okay. All right. Let's practice this. Okay. Complete and balance this reaction and show the product that form. Okay. So potassium react with hydrobromic acid. You can guess that this is just a single displacement reaction. Potassium bromide, of course, is formed, and hydrogen gas. Okay. Don't forget to balance the equation. So 2 hydrogen here. So I put 2 in front of HBr. So we have Br2. So we have to do 2 in front of potassium bromide and then 2 in front of potassium. Okay. All right, next one. Calcium react with sulfuric acid. So calcium pair up with sulfate. So you get calcium sulfate. So, and hydrogen here become hydrogen gas. All right, everything's balanced out. We're good. All right.